Hello, this is the last question of part A, and this video is part 5. We were solving this midsum paper. Let us see the last question here in part A. Explain in words what does this data type declaration mean? So, what is the variable name here actually? ARR. Okay, that's what we are defining. An int I, where the I is the identifier, I can call it as an identifier or a variable name. Here, ARR is a variable name or a identifier. We are trying to say what type it is. Now, int I means is very simple. I is an integer. Character star B P C. If I say it's a character pointer. So, what we say, we do some built-in type, data type of the C language, and then we say is a pointer to C, PC. Now PC is a type which is of character star. Now, now suppose I am declaring an int array of 10. How do we understand this definition? The type declaration. So we'll start with this is what is called right side. We go into the right direction and left. Okay, it's called right left rule. Okay, this is the rule which is very generic that can be applied on any type declaration of what complexity you can imagine in C to understand about a particular variable being defined and what type it is. So if suppose I need to understand an integer array of 10 elements, I start with the ID identifier. ARR is an identifier. I go to the right, I see a square bracket, that means it's an array, and then I also see that there is a number inside. Then I say that okay, this is ARR is an array of 10 elements. Okay, that's I know this is what is 10 elements it is holding and it's an array. Now I don't know what type of elements are being held inside the array. I come to the left. So I need to go right and left based on where the definition stops there, and then I come here to the left and then I can go back to right. Okay. Here in this case we are not going back further because the type definition ends there. So we come to the left and then say oh integer. Then it's an array of 10 elements holding integer values. Now suppose if I have character star, okay, then I say P character of 10. Then I say PC is array of 10 character stars. Okay, or character pointed to a character. Okay, I will not say character star, I will say pointed to a character. So P pointed to C is holding 10 elements, is an array of 10 elements. Okay, each of them holding pointed to a character type. Okay, so pointers to character type because there are 10 elements, so we need to say pointers to character type. So this is how the basic definition is done. Now, given a definition like this, will you be able to apply a right left rule and say what it is? Now, let me write it here. ARR, here ARR is there of 5 element, and then I have put a star here, then a bracket. Now in C, if I have something, okay, inside the parenthesis, a star inside a parenthesis is a function pointer. Okay, that is function pointer. Now what is a function pointer? Suppose if I am defining in C integer a or function fn, and then say maybe void now, okay, it's not accepting any parameter, and then I write something and then say return. Now, what is this function fn? It's an identifier, which is the identifier pointing to a function. It's not a pointing to a function. It's a actually fn is an identifier for calling a function. So, in my main program, I have written a function definition in the same file, and then I am trying to call that function in the main program. What do? I say fn, and I have to put parenthesis. Okay, because I am invoking the function. So when I say this, I am not passing any parameter because this function doesn't expect any parameter. And then I am just saying fn equal. I am not putting equal to here. Okay. It is perfectly valid to have a function. even though it is returning a value, I can actually ignore it. Okay. One good example is a printf function. Printf actually returns number of characters it has printed, but hardly we actually assign that returned value of number of characters printed into any variable. That means it's ignored. So printf wants to give you something back to the calling function, but it is left to the calling function to either hold it in a variable, use it, or just ignore it. There is no harm in it. Okay. Similarly, I can in fact invoke it like this, or since it is returning an integer, I can even define an integer variable result equal to, I can say, f1. In that case, what I am doing, I am interested in assigning the value which is being returned by the function. Then it gets assigned to this integer variable. But I need to make sure that whatever type it is returning, I am assigning to the variable which is of the same type. So this is a normal function invocation. When I say the particular function name and then I put a parenthesis around it, then I am calling it. Even if I don't pass any parameter, I am supposed to put this parenthesis. Okay, you may wonder that, okay, why it is there? There is no parameter arguments passed to this function. Then I could call f1. No, you cannot call a function by just mentioning the name of the function. Okay, just by mentioning the name of the function, I am not actually calling it. That's one important point. Now, in the same file, suppose if I am declaring a pointer, okay, inside, assume that I am having this definition of a function pointer inside the main, assume that. Okay, suppose I write it that I want to define a function pointer to this function type. Okay, f1 function p, maybe I write it a function pointer. Okay, this function pointer is a function pointer. If I have to say, I need to make sure that I put a star here and parenthesis there. Okay, f1 ptr is a function pointer. Okay, and I need to say this. That means it is not accepting any parameter. Okay, if I have to do this inside this, no, I can say here. So f1 ptr, I'm coming here. Okay, it's a function pointer, and this parenthesis I need to put here and then say leave it blank. That means it's a f1 ptr is a, I go to the right, nothing is there, it's not an array of function pointer or something, and then come back and see that star and then close parenthesis, pair of parenthesis, then f1 ptr is a function pointer, then I come here and see this, then which accepts no parameters, and then it returns integer. Okay, then I have to say int. Now this, if I say, actually I have successfully defined a function pointer which can hold the pointer to this function. Okay, and which accepts no parameter and returns integer. Now in my code here, suppose, okay, what I will do is f1 ptr is equal to f1. Now f1 ptr is equal to f1 semicolon. Now if I do this, actually I am using this variable which is a function pointer. Okay, I need to assign a function which is actually accepting no parameter and returns integer. So f1 ptr equal to f1 is a valid assignment. I am assigning the address of the function being defined in the code area of the program. So how do I invoke it? Using the function pointer. Okay, suppose I have defined it here. So inside the main only I should call it. So I will put it here. Instruction f1 ptr open and close parenthesis. Then actually I am using the function pointer which has been assigned to the function which is defined here, and if I am calling it, I am f1 ptr bracket open parenthesis and close parenthesis, then I am calling it. It is getting invoked, and I can in fact assign it to the variable res. Then I can access the function, I can invoke the function either using the function pointer which has been assigned the value of the address of f1, or I can call it directly. So it is equivalent to, I can access a variable of I directly calling I, or I assign integer star ip equal to ampersand I. There I have to use ampersand. Here it is not compulsory. Okay, so I can in fact assign it f1 ptr equal to ampersand f1 is also a valid assignment. So both are valid, whereas you cannot say the same thing in iptr equal to I, where ampersand is a must. Whereas here, because this is a function and invoking is can be identified by whether you are starting with whether you are giving a parenthesis or not, the language has given you a freedom to either assign a fn, okay, actually using the function identifier, or you can use the ampersand thing also, because to be consistent with the rest of the parameter type, function pointer also is given this freedom. Okay, so this would have given you an idea of how function pointer can be defined. Now let us understand this. ARR is a 5 type function pointer. Okay, as an array of 5 function pointers which accept no parameter. Okay, good. Now I am going to put another bracket and then say start. Then see, once I have function pointer and then I have already done with my job of what it accepts as a parameter, then my job is to go to the left. See what is it returning. This function pointer is not accepting any parameter, but it has to return something. It can decide to not to return anything also, but if it is returning what? That means here I am encountering a star with a pair of parentheses. That means this is actually returning a function pointer now again. So I am calling a function with no parameter, but it is giving me a function pointer as a return value. So this is the thing. Now if that is returning a function pointer, then you should have some parameter. Then I come back and see what are the parameters it is accepting. In this case, I have put a empty parenthesis. Okay. Now I have put one more bracket there which may not be required. Okay, this this is actually not essential as per the language. Okay, now let me move this guy a little bit, create some space for you. Here I have put an int star. Okay, int star. That means in this place I have put int star. That means this is accepting, it is returning a function pointer which has no parameter to it as a parameter, but it returns an int star. It returns an integer. So it's actually an array of function pointers which accepts no parameters and returns another function pointer that also accepts no parameters and returns an integer, pointer to an integer. So if I have to define it in terms of words, this is how it has to be read. Start from the variable name ARR, go right, find array subscript is an array of 5, go to the left, find a star pointers, so array of pointers, jump out of the parenthesis, go right to find a empty parenthesis to the function that accepts no parameters, and then again go left, encounter a star that return a pointer. You know that it is a pointer, but jump out of the parenthesis to say that it is actually returning a function pointer to a function that accepts no parameters, and again go to the left and see a pointer that return a pointer, continue left and find an integer to an integer. So it is returning a pointer to an integer. So if I have to show you a piece of code which does this, now let us look at that. What I have to do is, now I have to have a type definition to make the code clearer. So I have defined a function ptr, okay, to a simple function pointer which is the return value. Okay, accepts no parameter and returns an int star. Okay, because this is the return type of our definition that we have. So I have put a type definition for it. Type def a function ptr which is accepting no parameter and returning an integer star. Now I am defining two functions. One is function 1 which returns an int star. That means it accepts no parameter. That means this function 1 can be assigned to it because it matches. Okay, it accepts no parameter and returns integer star. You can see that it is matching. Okay, I have to give a dummy pointer, right? So I have defined a function. Not only the dummy pointer, I have to write something code also into it. Let me write it. Now the definition that we have is here. Okay, and return type is of this type. Okay, return int star. Okay, this is int star which is returned, and then return function pointer type is of this type, because if I invoke a function array of functions, then it is going to return me a pointer to a function which is of this type, fnptr type. So I have put a variable which is actually holding a function pointer to a type which is of this. Okay, this function. Okay, first function, because the return function is of type fnptr. Okay, so that variable I am declaring to hold it. Okay. Now let us see how I am going to initialize it. Now array of I have to declare 5 only because there is a 5 element. So I am initializing it with the function pointer. Now that function pointer should be of this one because the function pointer which accepts no parameter and returns another function pointer of type this, right? So array should be filled with this function 2. So I am writing the same function 2 in all the array elements. Okay. Then now I have to invoke it. How do I invoke it? I said that array is holding the function pointer, right? So if I take the one element of that array of array of 0 is one invocation of the function pointer, right? It's not invoking, I'm accessing the function pointer. When I put a flower bracket around, parenthesis around, I'm invoking it. Now it is returning something. I can ignore it, but I don't want to ignore. I want to take that value which is being returned, which is nothing but another function pointer, which is nothing but a function 1. So I am assigning it to that function pointer. So another function pointer has come from that one of the array elements. Okay, I will see the show the implementation later. I am just assigning it to it. Now, what do I do with the function pointer? I can invoke it. So, invoking it, function pointer type is no invocation, no parameter will be passed, but I have to keep track of the int star which is coming back. Okay, I have to assign it to some int star. So here what I am doing is I am calling the function. I'm calling here. Okay, because here I am not calling it. Here I am return function pointer is there. So I am calling it with a flower bracket. That means I am invoking it using the function pointer. That means it is going to return me int star. That int star I am assigning it here, this variable which is holding an int star. So how do I get the content of that int star? I say star of return int pointer. I get the value. So let me summarize it. I have defined a type which is function pointer which accepts no parameter and returns an int star. Now I need to have a function of the same type which is nothing but a function 1. Now what the function 1 does we will see later. And then I am declaring another function which is the accepts no parameter and returns a function pointer which is of this declaration that we are trying to do. Okay, because accept no parameter and returns a function pointer. Okay, so this accept no parameter and returns a function pointer. So that is the one this function is. So function 2 is assigned here and then I invoke it, then I get the pointer to a function. I invoke it again, that returned value which is nothing but this function, and I expect it to return an int star which I am assigning it here, and then I am printing it using this. Now I have to make sure that the integer star that is returning is still valid outside this function. I can do it only if it is a static variable or a global variable. Now let us go into the implementation of this function. Okay. Now this is function 1. I declared a static variable. Now what is the static variable means? Even though it is inside the function, it is scope is there, but that pointer is still valid. So I get the address which is being passed. So the value can be I am accessing. See, remember when I am accessing I am allowed to access the I only within this function. The scope is limited to this function because it is within the function. But if I get the address out, I can still access this variable. Okay, why? That address is valid even outside because it is in the global area of this process. So I am getting the address out. Okay, I cannot access it using I because I will be not be even visible outside this function. So that's a valid program, but little bit confusing for people who are not familiar with this usage. So I increment it every time I pass the address of that. Okay, install, because this is the function definition. All right. Now what do I do? Function 2. This is the which is going to be inside the array. So this function, what does it do? It has to return a function pointer, right? I'm going to assign this address only. I have already assigned it. Okay. So this is supposed to return me a function pointer of this type. So what I do, I declare a local function pointer variable, assign the function 1 inside it because it is visible. This function is there in the same file. I assign the font ptr. I am also invoking it here once. Remember, I am invoking it once here inside this function, as well as I will be invoking it using the pointer. So there are two ways of invoking it. Here also is a function pointer. This also function pointer which is returned after it is returning. So So it is invoked twice. Remember, this function 1 is invoked twice, one inside this and one outside of. So what happens, every invocation it is going to increment the value from 100. So let us see what happens when I run it. Now every array element is going to hold this function pointer to function 2, and I am invoking it inside this. When I invoke it, okay, function 2, it comes here and execute this sequence and calls the function 1 once. So 100 will increment to until 1. Then it is returning the function pointer. Okay. Then I come here and call it here once again. Now again through the function pointer, I am in fact calling this function again. It is going to increment one more. So 100 will become 102. And then it comes 102 will come here. It will get printed here. Then I am going to call twice. Then 104, 106, 108 and 110. So 5 times it is going to be called. So let us just quickly compile and run it to be clear about what we are learning. So how do I compile it? GCC. Here I am not using any pthread library, so I can just say Q10 and Q10. That's all. Now Q10, if I do, this is what I am getting: 102, 104, 106, 108. Now this, once you understand, suppose if there is a requirement that I change the parameter of what this array of function pointers are and what does it return. Suppose if I write something like this, how do I understand it? Suppose my array is array of maybe 5, okay, star is a function pointer which maybe accept an integer and a character, and then this guy I wanted to return a function pointer which again may be float and double. So it accepts float and double and returns maybe a char star. Okay, returns a char star. So I can replace it with any type inside of this parenthesis as well as inside of this parenthesis. You have to understand that this is the one which is the function pointer being returned. Okay, so this definition can become little more complex by just giving more parameters or one or two or many parameters, and it may be returning a function pointer. Now you may wonder, why am I even breaking a head to make you understand about this type definition? The reason is there is going to be a signal function call. Okay, when you press Control C, is a signal given to a process, and that actually accepts a function pointer and returns another earlier function pointer. Okay, so that definition, if you need to understand of signal handler, you need to have a clarity on this particular type of definition and left right rule. So this stops, we come to an end of 48 discussion, and this code, if you run it and make modifications to it and understand it clearly, I'm pretty sure that this will remain with you throughout your life. Bye bye.